What are the changes that can take place in a substance if it is heated? First of all, its temperature will rise. If the substance is liquid, it will begin to boil when it reaches a certain temperature. It will then turn into vapor. Solid substances like ice or wax, when heated, will begin to melt at a certain temperature. This changing of a solid into liquid and a liquid into gas on heating is called a change of state of that substance. What changes take place when the heat in a substance is taken away? When we put water in a refrigerator, it becomes ice after some time. Coconut oil freezes in winter. It means that the liquid changes into a solid. Solid gets converted into liquid when heat is given. Liquid gets converted to gas when heat is given. Again, gas is converted into liquid when heat is taken away, which gets converted into solid when heat is taken away. When heat is given, it is denoted by plus heat, and when heat is taken away, it is denoted by minus heat. It means that for a substance to undergo a change of state, heat must either be given to it or taken away from it. Let us learn about the melting point and boiling point of a substance. Take 100 to 200 grams of crushed ice in a beaker. Stand a thermometer in the ice and hold it upright in the clamp of a stand. Place the beaker on a wire gauze on a stand and heat it. Make a note of the level of the mercury in the thermometer in minute intervals. Continue to heat the water even after the ice has all turned into water. Do not forget to record your observations. What did you observe? Even though heat was being supplied to the beaker, there was no change in the temperature shown by the thermometer until all the ice had melted. It remains at 0 degrees Celsius. Where does the heat supplied go? The heat supplied while the ice is changing into water is used up for changing the state. The temperature at which a solid substance changes into a liquid is called the melting point of the substance. Similarly, the temperature at which a liquid substance starts to boil is called the boiling point of the substance. For any substance, the melting point and freezing point are the same. Freezing point is the temperature at which a liquid substance changes into a solid when heat is taken away from it. The melting point and boiling point of some substances are given here. Many a times, you must have seen your mother putting the bottle in warm water if the lid is stuck tightly. Doing this helps open the bottle. This is due to expansion and contraction of a substance. Similarly, if two metal bowls have got stuck one inside the other, we place them in hot water. This helps to separate the two bowls easily. Like tin and steel, most substances expand on heating. That is, their length or volume increases. That is why, in the situation described above, the lid of the bottle comes loose and two bowls can be separated easily. Let us see an experiment that shows the property of expansion and contraction. As shown in the figure, fix the end A of a metal rod AB firmly on a stand. Keep the other end B of the rod free and touching the end C of a lever CD. The lever CD is a pointer which turns on a circular scale PQ. Heat the rod. The pointer moves on the scale from Q towards P. Why does this happen? When the metal rod AB is heated, it expands. That is, its length increases. As a result, it pushes the lever at end C and the pointer turns towards P. If we stop heating the rod, it cools slowly and contracts, and the pointer goes back to its original position. Thus, we see that solids expand when heated and contract when cooled. Let us perform another experiment based on the property of expansion and contraction of solids. Place a metal disc of the size of a 1 rupee coin on a wooden board. Now, hammer 2 nails on the board in such a way that the disc will just brush lightly against the 2 nails as it is slid between them. Now, holding the disc with tongs, heat it and try to pass it between the 2 nails. It gets stuck. The disc expands on heating. As a result, the disc which could just pass between the 2 nails now gets stuck. Let us gain information on the bimetallic strip and where it is used. Take an iron and a copper strip of the same size. Rivet them firmly together. Now heat the strip. The strip bends with the iron strip on the inside. This is because copper expands more than iron. In the bimetallic strip, we make use of the unequal expansion and contraction of copper and iron due to heat. Such a strip is used in electrical gadgets to help maintain a constant temperature. Now let us study about the expansion in liquids. Fill a test tube completely with water. Fit a glass tube in a hole in a cork and fit the cork on the mouth of the test tube. Ensure that the water in the test tube rises into the glass tube so that its level can be seen above the cork. Mark the level of water in the glass tube. Heat the test tube. Observe the level of water in the glass tube. We see it rising slowly. It means that, on heating, water expands. Now, stop heating. Slowly, the water goes back to its original level. It means that, like solids, liquids also expand on heating and contract when heat is taken away. Let us proceed to expansion of gases. Take an empty test tube. Fit its mouth with a cork with a hole. Take a drop of colored liquid into a narrow bored glass tube. Fit this glass tube in the hole in the cork so that the drop of liquid can be seen above the cork. Now, heat the test tube and carefully observe the colored drop. We see that the colored drop moves upwards. Why does this happen? The heat makes the air in the test tube expand. The expanding air pushes the drop in the glass tube upwards. Now stop heating. The colored drop falls back to its original place. This tells us that substances in all 3 states, solid, liquid, or gas, expand when heated and contract when cooled. Children, you all must have seen a thermometer. So, let us study about it. A thermometer makes use of the property of the expansion and contraction of substances due to heat. Generally, mercury is used in the thermometer for the following reasons. 1. There is a big difference between the freezing point and boiling point of mercury. Its freezing point is minus 39 degrees Celsius and its boiling point is 357 degrees Celsius. 2. It is shiny and can be easily seen. 3. It does not stick to glass. 4. It expands regularly and uniformly in all conditions. Let us now see the construction of thermometer. A glass tube with a uniform bore is used to construct a mercury thermometer. It has a bulb at one end filled with mercury. The air in the tube is removed to create a vacuum in it and the other end is sealed. To mark the scale, the bulb of the thermometer is placed in ice and the level at which the mercury settles is marked as 0 degrees Celsius. Now, the bulb is held in steam coming out of boiling water. The new level of mercury is now marked as 100 degrees Celsius on the tube. The distance between the two marks is divided into 100 equal parts. Each part shows a difference of 1 degree Celsius. Do you know how the temperature of a furnace is measured? Can we use the laboratory thermometer to measure the temperature? No, we cannot use the laboratory thermometer to measure the temperature of a furnace because its temperature is above 1000 degrees Celsius. A different kind of thermometer is used for this purpose. It is called a pyrometer. Pyro refers to fire. This thermometer is made by joining together two different metals like copper and iron. The metals to be used are selected on the basis of the temperature to be measured. When one end of the combination is held in the furnace, an electric current passes through it. This electric current is measured to obtain the temperature of the furnace. Let us see how to measure heat. Take 200 grams of water in a beaker. Take 200 grams of cooking oil in another similar beaker. Measure the temperature of the water. Now, place it on a stand and heat it. Stir the water occasionally. Stop heating after 3 minutes and note the temperature of the water. The difference between the two temperatures shows the rise in the temperature of the water in 3 minutes. Now, carry out the same experiment with the beaker with oil. Heat this beaker also for exactly 3 minutes. Note the rise in the temperature. What do you find? We find that the rise in the temperature of oil was greater than that of water even though the heat given to both the liquids was equal. What does this tell us? When equal heat is supplied to different substances, the rise in their temperature is different. Or, if we wish to see an equal, say 1 degree Celsius rise in the temperature of equal masses of different substances, different quantities of heat will have to be given. The heat required to raise the temperature of a certain mass of a substance by 1 degree Celsius is called the heat capacity of that substance. Specific heat. When heat capacity is mentioned, the exact quantity of the mass of that substance is not known. Hence, indicating the heat capacity does not serve much purpose. Therefore, a quantity known as the specific heat capacity or specific heat is used. The quantity of heat required to raise the temperature of 1 unit mass of a substance by 1 degree Celsius is called the specific heat of that substance. Let us proceed to the unit of heat. The quantity of heat required to raise the temperature of a substance depends upon the substance, its mass, and the rise in temperature. This principle is used to define the units of heat. They are the calorie and the kilocalorie. The heat required to raise the temperature of 1 kilogram of water by 1 degree Celsius is called 1 kilocalorie. It is easy to understand the specific heat of water when concept of kilocalorie and specific heat is understood. The specific heat of water is 1 kilocalorie per kilogram per degree Celsius. A study of many liquids has shown that the specific heat of water is greater than that of other substances. Sometimes the unit calorie is also used for convenience. The quantity of heat required to raise the temperature of 1 gram of water by 1 degree Celsius is called a calorie. In this table, the values of specific heat of various substances are given. Let us come to the last part of the chapter, calorimeter. The heat given by a hot substance or the heat taken by a cool substance from a hot one depends upon 3 factors. 1. The mass of the substances. 2. The specific heat of the substances. 3. The difference in the temperature of the substances. These factors can be used to find the specific heat of a substance. Let us see the apparatus. A calorimeter is a cylindrical copper container placed inside another container. The space between the 2 containers is filled with a bad conductor of heat like cork or sawdust. The bigger container has a lid made of ebonite or similar bad conductor. It has 2 holes. A stirrer can be inserted through one hole and thermometer through the other. A measured mass of water is taken in the calorimeter and its temperature is noted. The substance whose specific heat is to be found is heated to a certain temperature and then added to the water in the calorimeter. The water is stirred and the final temperature of the mixture is noted. From that, the specific heat of that substance can be calculated.